So these two examples I wanted to go over because they kind of are special cases here. So we're going to start off the same way. We're going to look and we're going to set up the limit. So we're doing the ratio test still. So these how we're doing these interval of convergence only applies to when you do the ratio test. So n approaches infinity for n plus 1 times x to the n plus 1. Now, this is not a fraction, so we're not going to end up being dividing a fraction by fraction, so we do need to divide by the original. So we have that. We have absolute values. Okay, and we want this to be less than 1. So go ahead and cancel some things out. So we know that when we cancel the factorials, we end up with n plus 1 on top. So I'm going to write that. And we're going to be left with an x on top. Okay, so if we ran the limit of this, I don't know if I wrote this in the other examples, but we're still thinking limit. I didn't write it in the last ones because there was no n to plug infinity into. That's why we could do what we did before. But if you still have an n in here, let's think about this. If we run the limit, we have infinity times x is less than 1. How is infinity times x going to be less than 1? So x has to equal 0. So this is only true when x equals 0. This whole limit. It's the only time it's going to be less than 1. Okay? So this is a special case because we don't have an interval of convergence. Okay, so there is no interval of convergence. This is only, this kind of is our interval of convergence. We're only converging when x is 0. It's just one value. So it's not an interval. It's essentially 0 to 0. And then the radius of convergence is, half of nothing is nothing. So radius is 0. Okay, so it's only perfect right at the center. And we were looking at that kind of idea when we talked about Taylor series, Maclaurin series. Back up here in these examples, we did have a center. Okay, we were centered at 0 on the first one because there's nothing being added or subtracted to x. And then here we're centered at -1. That's why our radius worked out. So from -1 to 1 is 2, and then from -1 to -3 is also 2. Okay, so our center on this one is 0, and we diverge if we go off of that. Okay? All right, another special case here. So same situation. We're setting up a ratio test. No. That infinity was not good. Still have not mastered the art of writing with my mouse. All right. Absolute value of -1 to the n plus 1. X to the 2. Now you gotta be careful here because we're multiplying n by 2. We need to put this in parentheses. So this is really going to be 2n plus 2 over, same deal here. Now we need another parenthesis. So again, that's going to be 2n plus 2 quantity factorial. times the reciprocal of the original. -1 tn and x to the 2n. Alright, so again, we're looking for this thing to be less than 1. So let's cancel what we can cancel. And we have this. I'm going to still have a limit, just because of what's going to happen. So in base -1s, we're going to be left with a -1 on top. So -1 on top. We have base x's. So remember, this is really 2n plus 2. So when we cancel these, we're going to be left with an x squared on top, and 2n factorial. So cancel factorials. So this is 2n plus 2. So we actually have two terms. Not two terms, two factors. We have the 2n plus 2 and the 2n plus 1 until we get to 2n. Okay, so here's the situation. If we run the limit as n approaches infinity for this, so the reduced ratio, we would end up with 0. So the limit is 0, which is less than 1. So what this says is no matter what x is, doesn't matter what we put that at, that is going to always be true. It's always going to converge. So we can say the interval of convergence is infinite. So negative infinity to positive infinity, we always put parentheses around infinity because you can't equal infinity. And the radius of convergence is infinity. So anytime you have a limit equaling 0, this is what's going to happen. You're going to have an infinite interval of convergence. And back to example 3, anytime you have this, your limit's going to be infinity. This is what you have to do. You have to have radius is 0, and there's no interval. We just have this value x. Okay? Makes sense? Hopefully. All right. As always, let me know if you need any help, and we can attend to that.